All right, so let's start. So the title of this presentation today is Embedded Edge Technology is Revolutionizing the Area of Machine Vision for Industrial Application. So I will actually talk about the convergence of different big trends. There's the major evolvement of embedded vision technology, machine learning, and the Internet of Things, ultimately leading to processing at the edge. And from our daily work, we can say that more and more former PC-based applications that substitute their big and rather costly vision systems to a more leaner approach using embedded vision technology. But we also see a lot of new applications popping up in all kinds of fields and markets, and how these new applications create values in ways that were not possible before. So setting up such systems can be complex, and there are quite a few challenges that come along. So today I will talk about the benefits and the setup of such embedded vision systems. Then I will outline 5 expert tips that we found absolute mandatory to consider when building these systems. Though this list might certainly not be exhaustive, it will give you a good idea of what kind of different hurdles the developers are faced with. And at the end, I will outline service and portfolio that Basler is offering to support our customers on their path to their embedded vision system by taking away the major pain points. All right, before I do so, a few words about Basler. So Basler is an industrial computer vision company from Germany with a global presence. We exist over more than 30 years with 800 employees spread around the major regions of the world. And we are the global market leader in the area of imaging components for computer vision. And we are the most trusted brand in industrial cameras. Looking at our portfolio, we're having a broad portfolio with over 400 active camera modules. And besides our home turf of area scan cameras, Basler is also offering 3D cameras, frame grabbers, components, and special medical cameras. Today, obviously, we will focus on the lower left-hand side, our embedded vision portfolio and services. So where we provide board-level cameras, development kits, as well as complete customized solutions. So as mentioned in the beginning, we clearly see a big growth in the usage of embedded vision systems. Now let's have a look at the technical development, market demands, and benefits that lead to the growing importance of embedded vision technology, and how all that impacts the computer vision market. So if you look at classic image processing systems, they typically consist of a camera and a PC. The performance growth of these applications came from Moore's law, which means that approximately every 1.5 years, the performance of the PC doubled. But this is not the case anymore due to limitations of CPU technology. And growth of performance actually went over to adding hardware accelerators to embedded systems like system on chips. And one very important type of hardware accelerator is an accelerator for machine learning or neural network processing. Machine learning consists of 2 steps, training and inference. On embedded systems, training can be done in the cloud for scaling reasons, while the inference is done on the edge, so on the edge device. And if you look at the performance, which you can get if you do the inference on a CPU, you see that it's fairly low. But it is really enhanced if you use this kind of hardware accelerator for the job. So for example, the latest NXP IMX8M Plus processor comes with such an integrated neural network accelerator. And since you don't have this kind of performance on a PC, this really drives the transition of the vision systems away from the PC towards the embedded vision systems. And this is a trend that you can clearly see in the industry now for years. And we are really confident that this trend will only continue and accelerate. But the advantages of embedded vision solutions are somewhat obvious. So the performance of embedded systems keeps growing at a fast pace, as I just laid out. So at the same time, embedded systems bring the benefits of low energy consumption, a compact design, a much leaner system architecture, leading to much lower material as well as operating costs. So you can really lower your bill of materials significantly. On top of that, you see in the industry that everything is getting connected, and there's a growing need for real-time applications, driving the processing closer to the sensors. And this is ultimately what you see. There's more processing at the edge, there's more use of AI and IoT applications. And with all these developments, there's basically an endless number of new possibilities for the use of vision systems. And of course, and this is what we cannot emphasize enough, is that you will see a lot of classic PC-based vision systems being replaced by embedded vision solutions. So to give you some application examples, embedded vision systems are both really diverse yet applicable across many different vertical markets. For example, here you see 3 drastically different verticals that utilize similar technology or a similar approach for this technology. So they can be used in factory automation for predictive maintenance or logistics for real-time quality control. And this can be with classic or machine learning algorithms, but also in the field of retail for customer tracking or smart shopping. So all these applications can profit from the combination of processing at the edge and network or cloud connection. And all these examples we've seen, they come down to a basic architecture when utilizing AI or IT. So you have your vision edge device consisting of a camera module or a processing board. From the cloud, the machine learning models are then deployed to the edge devices. In an IoT environment, usually your application combines the image data of more than one sensor, often the dozens, hundreds, or even thousands. And you want to collect the data of all these sensor points. Then the data from all the sensors is aggregated in the cloud, and this big data is then analyzed, and finally the outcome of the application is visualized on a dashboard. And as you will send around a lot of data, it is very important to make the amount of data as slim as possible. And this is called processing at the edge. So instead of sending the full image into the cloud and have all the processing done there, the inference is done on the embedded system, pulling out just the information you need to make it ready to be sent to the cloud as metadata. And the benefits are obvious. So sending data-rich images to the cloud can be very expensive and very slow as it uses up a lot of bandwidth. Also, the storage cost of the cloud must not be underestimated. The nature of machine learning models is that they require regular updates based on new data and new use cases. This can be done also via the cloud at scale. So of course, this is a very simplified overview, but generally we can say there are quite a few important components to consider before building an embedded vision IoT system. So here is just an overview of the components of an embedded vision system that you need to integrate. But you also need to take care of the specification and performance when setting up the system. So the camera modules, the processing board, the system and application software, and optional cloud or network connectivity. Embedded designs open up a variety of possibilities for new computer vision applications. And most important is that they are designed as one system and work seamlessly together. By taking our long experience in developing such applications, we worked out 5 expert tips that we would like to share with you today. So the 5 tips are the following. So consider the embedded vision system as a whole, have the system developed by a single source, know your processor architecture, consider critical framework conditions, and make a proof of concept. So let's start with tip number 1. So consider the embedded vision system as a whole. So when you purchase an embedded vision solution, it is extremely important to consider the system as a whole and not just looking at the individual key components separately. So the camera and the system is more than just an accessory. In an embedded vision system, image acquisition and processing are closely linked. So if a powerful processor is connected to a webcam, you usually do not get the result you desire. So because the whole system can only be as good as its weakest component. And to work around this error, you should really design your system detached from a single component, like a specific SoC or a specific sensor. It is better to go back to your application requirements and then select the individual components. Tip number 2, have the design system developed by a single source. So another mistake is often made because embedded systems are not perceived as a complex architecture. So often the development of individual key components and technologies is carried out separately rather than in the entire system. So for example, cameras without processing or an interface without application software are tested. So when implementing the overall system, the components often do not interact with each other in a high performance manner. And then this delays the development project. And of course, the cost and time to market explodes. Therefore, it is better to have the system developed by a single source and choose the development partner with proven expertise in the various fields of processing, vision and system software. Tip number 3, know your processor architecture. So many camera modules have an image signal processor, so an ISP to pre-process image data. Here, for example, the color calculation or noise reduction can be done. And these existing resources are often not used, or the workload is unfavorably distributed on the embedded CPU. And this results in an oversized system design and then, of course, also in exceeding costs. So therefore, make yourself familiar with performance and target functionality within the heterogeneous processor architecture. So acquire software know-how and find out what an algorithm can be calculated best. So it may also need to be adapted for dedicated processors in the system architecture to achieve optimal performance. Tip number 4, consider critical framework conditions. So in the first system design approach, one often does not think about whether the individual components such as sensors or SoC will be available over a longer period of time and in serious production. Instead, pure functionality and often also the price are the main focus during the first system design and prototyping. Only to find out later that the components for the serious production are not available at all, or the component was even discontinued without any replacement. So, and then often a costly redesign or reintegration of key components are then necessary. It is therefore recommended to consider critical framework conditions such as the long-term availability of the components at an early stage of the initial system design. Also, you should use standardized protocols and interfaces. Tip number 5, make a proof of concept. So the performance of embedded vision systems is often overestimated. The development is purely made on the assumption of theoretical performance parameters. So these are true for each component as such, but not when they work together. So when the system is brought to life for the first time, it often turns out that the desired performance cannot be achieved. And in order to minimize risk, a proof of concept is often useful for system validation before the start of the development. So this may allow to replace core components early in the development process. All right. So this was quite a few information for you. Of course, this list is not exhaustive. There are a number of traps that you can fall into in the field of computer vision, but you should not get discouraged. The possibilities are definitely exceeding the risks, and it's definitely worthwhile working on it. So get advice for your projects, and that expert helps you. So this is what we would like to offer to you. So we offer the help over the complete journey. So from solution consulting that can include a POC if you want to the development of all hardware and software components. And this also includes, besides system software, also the application software side. And we can take care of the production. So we have the production facilities in-house that we can really scale up your solution and your application. And we will also take care of lifecycle management. So we will really help you to create the complete embedded vision solution. You will get everything out of one hand, as we are having in-house resources, and additionally a well-established and growing ecosystem with strong partners at our side like NXP, NVIDIA, or AWS. So the products and services will be delivered based on our knowledge and expertise in the field of vision, and they come along with our well-known quality standards in the computer vision industry. And the needed longevity, of course, to secure yours and our future investments. So we focus on the simple integration of embedded vision systems. In this way, we help our customers to develop applications that completely meet their expectations. So for our standard and enabler products, we already did a lot of integration work in case of camera drivers and images for specific processes. And here we have a strong focus on the NVIDIA Jetson platform as well as the NXP IMX8 platform. So you can really start integrating right away embedded vision into your application. And therefore we have also a different kind of embedded vision kits. So first, our so-called add-on camera kits to add vision to your existing partner processing board. So if you're using the Jetson developer kits or the official evaluation kits from NXP for the IMX8 family, you can simply add vision to your boards by adding those add-on camera kits of ours, where we have the cable, the camera, the cable, the lens, and the software stacks that are necessary to make them work seamlessly together. But we also provide full-blown development kits with camera, processing board, and all necessary components so you can start prototyping your application right out of the box. But our portfolio also covers software. So we're providing all the necessary software stacks for cloud connection that you can use, for example, for Amazon Web Services. And also, as I mentioned, the application software where we can offer you with classic or machine learning application software models. All right, already coming to my final slide. So I would like to tell you about our latest highlight, our brand new embedded vision processing kit. So as mentioned, we think it's the best approach to get all important parts of a vision solution from one hand. So processing, vision, and the system software. And so that you can guarantee that they're seamlessly working together. And therefore, Basler is now announcing this new vision processing kit. So it's based on the NXP's IMX8 Plus application processor, and it can be used with Basler MIPI cameras, USB camera modules, as well as Gig-E cameras from Basler. So you are really flexible in the use of this board. And of course, it's supplied with our unified Pylon API. And it has a vision optimized design. So from all the learnings from our embedded vision projects, really stripped down to the core features that you would use in a vision-based application. Of course, this will not meet 100% of your requirements all the time, but it will give you a very good base to work on your individual project, and it's really easy to customize for us. So it is based on the IMX8 Plus I mentioned, and it gives you a great price-performance ratio and all the longevity that is needed in the industry. And what it makes it really special is that it is ready for mass production because it comes with industrial standards and design. So the PCB and the connectors have all the needed design and grade, and that you can really use it as a mass production processing board. So it's not like your typical development kit that you buy that's basically only meant to be on desk proof of concept development kit where you have your first prototyping, but then you basically start from scratch looking for the parts that you can really build into your final application. And with this kit, you have all in one. So you can do your prototyping, your first proof of concept, and if it works fine, you can really immediately start designing it into your final application. And again, it comes with a very flexible design, so it's easy for us to do a little bit of customizations here. And this really leads to much quicker time to market than the usual way where you would start with a development kit and then basically starts from scratch. So I think this is a really exciting product for us because it really gives us a carrier board design that is really specified and specialized for vision-based applications based on all the embedded vision projects that we executed so far. So our promise to you with this kit is the fast time to market for your product. So you would get everything out of one hand from a vision expert. All right. And this is already the end of my presentation. I hope you enjoyed it and thank you very much.
That was great. Thank you very much for that. We've not actually had any questions posted whilst we've been talking, but if anyone does have any questions, please just use the raise hand button now that's on your screen and we can unmute you so you can ask the questions and find out any information you may want. So, doesn't look like we've got any takers on that either, so you must have explained it very well. In which case, what we'll do, if anyone does think of any questions or want to borrow any kit for trials or see a system, please don't hesitate to contact us and we can sort that out. If it's something we can't deal with, we always talk with Basler anyway, so there's not many problems we can't resolve. If there aren't any questions, then we shall have a short break now, and we shall restart at 2 o'clock UK time, and then we'll be looking at environmental considerations when you're putting cameras, machine vision systems in real life situations. So we'll see each other in a few minutes' time.
All right, thank you very much. Bye.